activity?
So 9.1, question number 8.
Let me share my screen. Nine point one. Which activity? Question number 8.
Yes.
Okay.
Yes, so this one. Sir, in the under root, it is 1 minus x squared by 9 minus y squared by 16.
Yes.
I say 1 minus something, right?
Huh.
If this something becomes more and more negative,
Okay. Hmm.
then square root increases. I mean,
Then
1 minus, say, sir, suppose I start with that, let this something be 1. 1 minus 1 is root, 1 minus 1 is 0. Root of 0 is 0. Right, sir? Suppose this something becomes 0, then the square root becomes 1. Suppose this something becomes negative 1.
Negative
becomes
1.
root 2. Yeah. Negative of negative 1, then it becomes 1 plus 1, that is root.
Okay, positive, yes.
The more the something becomes negative, the root increases.
Yeah. So, continue.
Sir, I suppose the option given in this question is wrong. The solution is wrong, I suppose, sir.
Okay, so which okay, let me check which option is going to be wrong and right. So this question is the correct option with respect to this, asking for domain and range. So,
sir, domain, how could domain be is less than 1? It should not be greater than 1.
suppose if it is greater than 1,
then the negative value will come.
then it gives inside the negative, but the root over the negative, we don't have any idea.
Yes, sir. Because we don't have it in the real domain. It would be in the complex domain.
Yes. And range over it is how you are getting this? As
sir, I don't know. Yeah. I have
this
doubt in this
portion
how
is
the
going
range
to
is from 0 to 1. The
Huh.
range should be from 1 to infinity, I suppose.
No. So
No.
how could we need to die? Like you, whatever
Yeah,
you get, the
less
inside.
than 1.
Yeah, less than 1 should be, no? This.
Yeah, 1 or 1 you will get, so it won't come.
Yes, sir. That is why I am supposing this to be something.
Huh.
Right? 1 minus something.
Yes.
So it would always be the something. There is no down limit of this something. It can be minus infinity to. It could go to minus infinity.
No, 0 to 1.
Making the square root to be positive. The more this something gets negative, the more is the value of the square root. So the range should not be limited to 0 to 1. It should be beyond 1.
So, okay, no issue. But okay, you got right. What is inside this portion should be less than 1. So it is going to be domain for this.
I am not getting the point of range.
So range is, see, this whole function. This I'm saying, this whole function is root over minus something. So root over minus something. What it means that?
No, sir.
What it
can you write it once, sir? Can you write it on a sheet, please?
Yeah. Okay. So yeah, we have fx is equal to root over 1 minus x square by 9 and y square
minus y square by 16. So take minus 1 common from x and y terms.
Okay. Okay. So this we can write 1 minus x square by 9 plus y square by.
Yes. Sir. Now the more the less this, let us call this something like x square by 9 equal plus y square by 16. Let us call this something. When the value of this something becomes less than 0, it becomes negative, right, sir?
Something
suppose
0
is minus
to be negative.
Suppose, yeah, the more its value is in negative form, like this something becomes minus 1, then minus 2, minus 3, minus 4,
yes.
minus 100, minus 1000.
Yes.
The value of the square root increases. So in range, we have to evaluate the square root, sir.
So no, actually what is happening here? Okay, let me first only see this portion. This portion is never going to be negative, right? This portion,
Okay.
because this is square, this is square. So this portion is never going to be negative. And you are
We are applying.
and you are
We are applying like
subtracting 1
yes.
minus some positive number. So this number is always less than 1, right? This number is,
Yeah, less than equal to.
it would be always less than or equal to 1, because you are subtracting something, let's say a 1 minus something. So this number is going to be always less than or equal to 1. So whenever you are taking the root of it both sides, what it gives, it should be always less than root of 1 is going to be 1 positive root. So
Yeah,
means
I was
whatever
making a
you have.
mistake in this, sir. Okay. Now I got it, sir.
So is it clear?
Make it yes.
So if you think like this way, then it may be exact whatever you want to find. Okay. Thanks.
Now,
Thanks.
now I got
Yeah,
it.
that's
Thank you,
a
sir.
good thing to discuss. Okay.
So I had to ask you something regarding the week 9 graded assignment.
Okay.
Sir, like normally before quizzes, the deadline of the assignment gets a little extended. So this time also will it be extended for week 9?
So what is the end date of this week 9?
So it's written as 6th July.
So I don't think so. It is going to be extended.
Yes, sir. It will not
Because
get.
if it is like in the after, like suppose for week 10 it may, I'm not sure, it may be,
Okay, okay.
but for week 9 it is difficult,
Okay,
because it is
so
ending the before 4 days of which.
okay. So for week 10 it might get extended.
Yeah, it might, I'm not sure, it might.
Okay, sir. Thank you, sir.
Okay, so yeah, if anyone
Sir,
have
would
doubt.
there be a
Sir, if you
would there
don't
be a
mind,
revision session for quiz 2?
Sorry, Bhavna, yeah, I will take that. Naveen, sorry, do you
Sir,
want,
sir,
sorry,
would there be a
Deepti
revision
or
session for quiz 2?
sir, can I ask you a doubt? 9.2 last question, 10th question.
yeah, sure.
If
Yeah.
you don't mind, can you solve it for me? Because I forgot totally the trigonometric.
Okay, which activity?
9.2, the last
Uh-huh.
question. Yeah, last question.
And what you are saying, Naveen?
Sir, I was asking about the revision session of quiz 2, so that something important all that would be discussed.
So two revision session is there for one is on 6 and another is on 8. So we have this last question, right?
Yes, sir. Yes, sir.
So this one we have this question, fx is equal to this.
Huh.
Okay, we have just do the partial derivative. Okay, so you have with the problem sign. So let's take this.
Not able to find the partial derivative.
So f of xy is equal to e power, okay,
E raised to 4, e power 4 into x plus y.
into sine
Sine 7x minus 4y.
7x
7x minus 4y.
this is we have function.
Yes,
So
sir.
only the asking for partial derivative in this need to
Yeah.
be find first partial derivative.
Yeah. 4
So
del f.
del of del x of f equal to here we see both function, like this is the multiplication of two functions. So and assuming to y as a constant, this both function contains x. So we have to do with the same multiplication rule of this, what is the derivative multiplication rule is there, right? We have to first derivate this or any one of them and
Yeah.
leave it here as it is, and then another one, like that we can.
Derivative. Yes, sir.
So sine 7x minus 4y, and the derivative of this portion
E raised to 4x plus y. Okay.
4x plus y
And I think it is 4.
is 4.
Yeah. Yeah,
Because
only
y
4.
work as a constant.
Yeah. Yeah, that. Yeah.
If you, so something, yeah, okay, this is 4 here, so only we can write here 4. This is we have. and
Yeah.
del y of f is equal to, oh sorry, and we need to add still. Oh sorry. The next
Yes,
one
sir.
is
Uh,
uh,
uh, Sine e raised to 4x, right?
cos
Cos for minus 4.
cos derivative of sine is going to be cos. The exact
7.
is now 7.
7. Yes.
So
Yeah.
okay, so this
It's going to be
now for del y of f is equal to
uh,
uh,
this time.
again we have to assume y x is as a constant and
Oh,
y as a variable.
yeah.
So the first one is the same as whatever we will get here, the same. Only
Same.
yeah,
Only the
same.
quotient will change, I think, 7.
No, the first one, like assuming to be this one, let's derivate this one, and this is as a multiply.
Oh, okay.
So sine 7x
Sine
minus
7
4y,
x.
and all will be the same. The first one,
Yeah.
and for the second one, we let's assume this is as a multiple,
But e raised to 4x plus 4.
and again this is cos,
Cos minus 4, I think.
and here is
No.
going to minus 4.
Yes. Sir.
Now need to add it here.
Mm.
So let's add here. This is going to be, this is 8 times e power x plus y 4 times, and sine 7x minus 4y, plus if we add this we will get this is both are same, no?
Mm.
Going to be 3 e power
3 e power
e power x 4 times. This is cos 7x minus.
7x minus 4y.
So what is in this question? K times some function,
X.
same function f is going to be there.
Yeah, 4 del f by x
If this
plus
is equal to
k.
4 times this, still remain to I am making.
So that will be
This is 4 times del of plus 7 times.
yes, sir.
So this is 4 times plus this is 7 times. So this
Yes.
4 times is going to be 16 here, and this is going to be 28.
We have to multiply. Oh, okay, sir.
Now this is going to be 20, yeah, 28, and this is going to be minus 28.
Yes.
Okay. Now if we add these two, we will get here 18 plus 6. How much? This is going to be 44, I think. And now, and this is going to be cancelled because of
Yeah, plus and minus. Yeah, okay, sir.
opposite
Now
side.
yeah, now I understood that. Thank you, sir. Thank you so much.
Because in the is solve with us is a considered in bonus mark? No, no. Solve with us.
The attendance, right? Attendance is considered, right?
Oh. So for live session there is no bonus mark, I think. Only
This term there is no bonus mark for attendance.
for live session. Attending for this course is there, like how much you are looking them, I think.
Yeah.
Reviewing that. Okay.
Sir, I have doubt in 9.6, sir.
9.6.
9.6, question number 9.
Okay, gradient.
Yes,
This is like question number 6.
9.
9. Okay.
Actually, 8 and 9 are connected, sir.
So what is doubt here?
Doubt, sir, is I'm after differentiating, I'm getting C.
Hmm.
C in question number 9. Option C and option last one.
Okay.
Yeah.
So which are so is that not matching with that option?
Yes. from where I'm getting this signum function,
Signum
sir?
is, the signum function is just sine of something, a sign of like signum is written here. It could be
Yeah, I know about signum function, sir, but I'm not getting that answer, sir. Can you please solve?
this portion.
Yes.
Okay. Okay, we have f of xy is equal to x square. So this one is clear to all of you, right? I just quickly did the calculation. Hope.
Yes, sir. Very clear now. Thank you, sir.
So this is x square plus y square sine root over 1 upon sine. So sine 1 upon root over x square plus y square. So this we want first. First, let's find this one, then we can.
Yeah.
So syllabus for which Santosh is asking syllabus. Syllabus is still week 8, from week 1 to week 8 for quiz 2.
Yes, sir.
So let's assume, as we did here for the previous question. This is going to be, this is again, this question is this one is the first
Sir,
function.
should we remember
sir.
all the trigonometric derivatives?
Yeah, at least you should to remember that. Otherwise, it may not be given also. And also in the math one formulas are given, or you have already, if you search in Google, you will get. So yeah, please remember those at least derivative of not only sine, e power, log, something on.
Basically, all the trigonometric derivatives.
Yes.
Logarithmic also.
It should be, yeah, just remember that log also.
Yeah.
So assuming to be this one, let's derive this function and assuming to be as a multiple of it. So this is 2x sine root over something. Okay.
Yes, sir.
Plus
X square plus y square.
X square plus y square.
Yes, cos.
And this is cos 1 upon
root x square plus y square.
Now next is
Minus 1 by 2.
Minus 1 by 2.
1 upon 2x, sir.
2x will be there.
Yeah, 2x upon x square plus y square, 3 by 2.
3 by.
Yeah. Yes, sir.
So this is going to be how we are doing. In the first derivative, first find the derivative of sine. With respect to x, first derivate the sine, which is going to be cos with the exact inside what we have. Now derivate this portion, like you know the composition, derivative of the composition function. So this is happening here. First derivate sine, then as it is will be here inside what we have. Now the next one is, let's derivate this one, which we will get this one. So this is 2x sine x square plus y square plus, here this is going to be cancel out with 1. So yeah, so it is going to be 1 upon root over x square plus y square. And this is going to be 2. Here is 2 is going to be cancelled here. And x will also come here. It is minus time, minus x. This is cos root over x square.
Okay, sir. Yes, sir, I got it. Sir, if we take here y is equal to 0, then
y is going to be 0, then you know, if
yes,
we
sir,
have like whatever you will sign get here, it is going to be
signum. Yeah. Yes,
that it is.
Okay, sir. Again, in question number, can you see?
May I interrupt? Sorry to be interrupting, but how does it equal to mod x? Can you actually clarify that one, please? Sorry about the interruption.
Yes, Ravi. Yes. So yeah. So this is now we got this one. Okay. So asking for the partial derivative of x and substituting y as 0. So this is going to be 2 sine 1 upon, this is
mod x.
So
okay.
This one is like 1 upon root over, if you want to, what is going to be this one?
That's going to be 1 by x actually. I mean, like
mod x.
So this is
mod
going
x.
to be mod x.
Yeah.
The reason is you don't have idea about it. X is going to be positive or negative. first thing.
Okay.
And whatever you are taking root of it, so suppose it is negative, then it is going to be positive again, and something you will get exact x. But this is only root over something, so you always it will be positive. So that's why it is going to be mod x.
Okay. Thank you. Sorry about the gentleman was asking something. I interpreted. I apologize.
Yeah, no, it's good. It's good. It's
Excuse
good.
me, sir. Sir, can you please find the continuity of this function at 0, 0?
Okay.
Yes.
Okay, so I will take this question in the later portion, like when we discuss this continuity of it. Okay. Let me finish, then I will surely discuss this question. I just noted it here.
Okay.
Then
Okay.
let's finish this the one by one which I have previously discussed. Derivative.
Okay, sir. Yeah.
Okay. So anyone else have doubt, or let's continue with the previous one section? What last time I did here. So okay, if you have doubt, please stop me, or otherwise. Last time I discussed about the definition of a function. So just recall what is the function in the multivariable is. I'm just going to be the as writing like this. So suppose this is n and this is r. So this kind of function is going to be scalar valued. This is called a scalar valued function. This type of function is called a scalar. It means that you have some variable and it give a real number only. You have expression with relating to be x, y, z, how many variables are there. It will be written as x, y, something set. Only it will give only a real number. So this is going to be a scalar value function, and vector valued is Rn to Rm. Where if you are defined here separately, so assume it here n is also greater than 1 and m is also greater than 1. This kind of function is going used to call it vector valued function. So for example, if this is suppose this is f is from R2 to R3, so this function is going to be xy y square x square. As you can say, 3 coordinate you will get in this output in output, and 2 coordinate as here this is R2, so 2 coordinate will be for the input. So this is going to be called a vector valued function. The next one is one partial derivative. That's all this about knowing to be the vector and vector valued and a scalar valued function. The next one is partial derivative. So partial derivative, suppose you have a function. Generally, we will mostly study about the only this vector valued function. If you study enough with this one, easily we can study this kind of vector valued function. So let's focus on only scalar valued function. Suppose you have a function from Rn to R, scalar valued function. Okay. So partial derivative means how many variables it contains this function. Let's say x1 to xn variable it have, and this is going to be a scalar value. So this will give us some relation in x1 to xn. Only an output you will get. This gives a real number. So partial derivative means derivate this function only with respect to single variable. Like suppose derivate it with respect to x1 or x2. So for x1, if you are derivating it, we used to denote it is used to denote like this, and the definition of it, like what is that? The limit definition is limit h goes to 0, f of x1 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 to xn plus h time 1 0 0. This 0 is going to be the for making n time including 1, minus value at that point upon h. So this is the partial derivative with respect to 1. If the partial derivative with respect to ith variable, if we assume it, so it is going to be like this. This is x1 to xn, and this is h time 1. This is now 0. So suppose somewhere is ith, so it is going to be 1. At ith place, it is going to be 1, and rest Scalar is going to be 0. Okay. Now minus value of the function at that point upon h. So this is called the partial derivative with respect to ith variable. The same thing whatever we are doing here for the with respect to some variable. Okay. So this is thinking like a vector in Rn, and this vector, this vector is a unit vector with respect to ith axis. Suppose this is for if you have 3 coordinates, so this is x axis, this is y axis, this is z axis. So for the unit vector in the direction of y axis is going to be 0 1 0 kind of. So if you have nth axis, okay, so in a unit vector in the direction of ith axis is going to be 0 1 0, where 1 is going to be ith axis. Sorry, 1 is going to be ith place. So this is one unit vector in that axis, in the direction of axis, ith axis. So ith axis means it you can name it as like this is x1 going x1 axis, this is x2 axis. So in the direction of xi axis, so mean to say ith axis means this mean to say. Now once you know that, so what we are doing, we are multiplying a positive number with the unit vector in that direction, in which direction we want to derive it. So there is a term directional derivative, the same definition, but here is the differences is we are derivating with respect, we were derivating in the direction of axis. Okay, but suppose we want to derive this function in apart from the axis, like some any specific direction, not only suppose in this direction, let's say this direction is u. In that case, how we will write this partial, what is going, not partial, this is called a directional derivative. In that direction, how we will derive it? So the definition in that direction is used, this is denoted as d, means derivative in direction of u of the function f at some point if you want to find the directional derivative. Okay, so let's assume that point is a. So it is written as f of f limit h. Again, says please match with this definition. There is no differences, only the small differences. This unit is vector is going to be changed with the that u. So if you assume that this a means some coordinates will come, many it contain, if we are assuming a is, so it is going to be a1 a2 kind of an. Okay, so this a, or in the video lecture you have seen sir is writing it as a tilde. So if you assume a tilde, or for simplicity I am just assuming a is only, I am not going to write here tilde here. So a is actually a1 to an. Okay, and u is actually again in that direction if you want, so u1 is going to be u1 to u1, but the condition is this, as here for the axis kind of doing, we are for the partial derivative, this is going to be unit vector. Similarly in u direction, if we are trying to get the derivative of the function, so it is going to be this vector, this direction is going to should be in the unit vector. And if you have any vector, suppose v, so how we will make it unit? Just divide with the norm. So but we are assuming here u is in unit vector, so the definition of directional derivative in the direction of u is written as h goes to 0, f of a, that a means a1 a2 plus h time that vector u minus value at that point of the function upon h. So see that this is a1 a2 u is actually u1 u2 u1 and minus f of a exactly as here is happening. So this is called directional derivative of the function at point A in direction. This is all about we studied in the previous session. The next one is we are talking about limit of function. So I have that slide also. Maybe today evening I will give to operational team to upload this if you want, or otherwise it will be uploaded. So last thing I were discussing about, yeah, sequence thing. I'm not going to discuss the sequence in the Rn, R2, R3, Rn in any space. That is easy. That is a simple thing. If you didn't know, just please go through that previous session. I just discussed about what is the sequence in Rn and what is limit. That is, it will take time to tell you again. And in that session, I very slowly, neat and clean, we just discussed about what is limit also and what is the sequence in Rn. What is the meaning saying to be sequence in Rn? What is divergent? What is limit of a sequence? So this is all about we discussed in previous session. So remain to the limit of function till where we just something we discussed but stopped there. Okay, so let's continue with the same definition as in the we were discussing about the limit of function in limit of a function at a point in the terms of sequential approach. Because why we are doing, I will tell you two approaches. This is sequential approach and another one is curve approach, that is called curve approach. And curve approach is usually like used to find the limit. It will help you to find the limit. Sequential is somewhat difficult. It is generally used in proving when a function don't have limit, and it is mostly used in the proving theorem kind of like proving. We use this sequential approach is generally used to prove theorems. The curve approach is easy also, and also it help to uh, help to neglect that function have limit at that point or not. Okay, so but it is easier than the sequential approach. And another thing is the only in this course or in the whatever sir have taught, to find limit is only we have the tool sandwich theorem. You see that, let me show the uh, video itself. Only we have tool to find limit is sandwich theorem, or we can substitute only two tools we have to find a limit of function is either we will use sandwich theorem, or we will substitute exactly, or we will what is solve the expression or rearrange the term and then substitute value. These two tools we have only uh, to find a limit. So this is the sequential approach to find a limit. Let me recall it again. Then we'll discuss the sequential also and sandwich also, sorry, the curve approach, sequential approach, curve approach and sandwich approach or substituting approach to find a limit or neglecting or a limit is exist or not saying to be set. So if we have a function, okay, suppose we have a function scalar valued. Generally we talk about a scalar valued function. So if suppose we have a scalar valued function, let's say from Rn to R, and we want to check is this function has a limit at a or not. So what is the sequential approach is, we will say this function have limit L, okay, we will say this function limit have limit L if, what is if, that what is if, when we will say this L is going to be limit of this function when where when okay, let's say this x, or maybe in more explicit let me write that. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. You are audible.
Okay, so suppose we have function this fx, where again I am x is actually saying to be the writing to be a tilde means x is actually x1 to xn here, as we have in domain Rn. So or let me make it also tilde here. So this function has limit L as x tilde approaches to a. Again, let's assume a tilde. A tilde means saying to be again a1 to an. Okay. So as x tilde is approaching to a tilde, we will say f has limit L if, what is if condition is that if the sequence f of an is again, let me make it a tilde here. Okay. A tilde means saying to be again the sequence in that space Rn. Okay. If this sequence approaches to L, okay, if this sequence is approaches to L, and this is approaches to L for all sequences a tilde, sorry, an tilde, which approaches to a tilde. So what I mean to say, again, let me repeat again slowly, as x tilde approaching to the particular point a tilde, okay, we say this function had limit L if this condition, this sequence, if you put a sequence in place of x variable an, okay, this sequence is converging to that exact whatever we are saying the limit is going to be limit, okay, and this condition is true for all sequences which is approaching to a means 80. This is the mean for we just talked about this sequence in Rn to R. For simplicity, what I mean to say, we have a sequence generally in the calculus portion. What I mean, so suppose I have a function fx, this is from R to R, general function, one variable function fx is equal to x square. Suppose we have this function, okay, or let me make it with the contradict. Suppose sine 1 by x, okay, suppose we have a function fx is equal to sine 1 by x, okay, and we want to find the limit of a sequence as x approaching to 0. What is going to be, as x is approaching to 0, is that limit exist or not, or what is going to be the limit of this function fx, okay. Okay, so suppose we have a sequence, I am writing like so. What we are choosing sequence here, such kind of sequences which is approaching to a. Our case a is here 0, so we have to choose a sequence which is approaching to the point where we want to find the limit of function. So as here our a is 0, so I am choosing a sequence an which is approaching to 0. Okay. Now the corresponding sequence with this corresponding sequence means here f of an means we are substituting the in place of x just 1 by n. So now this function is going to be, this function is now changing, we are substituting as here 1 by n. So now it is going to be a sequence, and this sequence is sine 1 upon 1 by n, which is sine 1 by, so sine n, sorry, this this sequence is sine 1 by n. Now what is saying, we have a sequence approaching to a, okay, which is approaching to 0 here for our case. So this sequence should up, if we are saying it have a limit, so it should approach to that limit. Suppose I am saying this function has limit L as x approaching to 0. Okay, so that means this sequence will also approach to L, because our this sine top portion, this 1 by n is approaching to the limit point. So that means our function sequence, when we change this function in sequence form, it should approach to L. But the condition is, as we assumed it is approaching to L, but what we got here, this sequence is not convergent, right? So how do we, like, I have a sequence and see that this is true for all sequence. Okay, this is true for all sequence. And if this is happening, it should go to L. But our case is, what is happening? We have a sequence which is approaching to the limit point, but what we are getting, the corresponding Fn. This is called Fn, Fan. Yeah, also you can say Fn. This sequence is not convergent. It means that we have a sequence which is not satisfying this condition, if condition. That means as x going to 0, this function don't have limit. Only using this sequence we concluded. So let's assume I have a sequence 1 upon 2n pi. Suppose I have a sequence 2n pi. Okay, see that this sequence is, what is the limit of this sequence? This limit of this sequence is 0, as just multiplied here 2 pi. Same sequence multiplied with 2 pi. So we have a sequence 1 upon 2n pi, and it is approaching to the limit point where we want to find the limit of function. So let's substitute here the corresponding sequence. What would be here? Sine 2n pi. Now limit of this sequence is what? Anyone can tell. Unmute yourself and tell me what is going to be the limit of this sequence 2n pi. Yes, Praveen, Ravi.
It will range from 0 to 1.
0.
Sorry, -1 to 1.
-1 to 1. How do you sure? This include, let me give as in here, this include pi also. For
Correct.
our case here is not pi, but here is pi included. So
Okay.
what is going to be?
Sine 0 is 0. 90 is 1.
1.
270 is -1.
Yes.
So that's the reason I'm saying it ranges from -1 to 1.
So here is not sorry, 270. This is, if you assume n is equal to 1, it is going to be 360.
360, correct. That is 0.
That is 0.
Yeah.
So whatever you substitute here for each n, it is going to be kind of multiple of 360. So in that case, what is going to be value of 16?
Maybe I should ask a question here. Is n an integer?
It is always going to be an integer and multiplied with
Then
the pi.
Then it is 0.
0.
Then it is 0.
So that is 0. So that means this sequence has limit 0. Now if you say this sequence, we have a sequence. So this sequence has limit 0, because if you substitute any n, it is always gives you to 0. Right? So this sequence has actually limit because of pi is multiplied here. but this sequence don't have limit. As n is going to be larger and larger, sign is going to be vary, sometime here -1 or sometime -1 or +1. But here as we have multiplied here pi, so it is always give a value, then you will check for, right? First evaluate the value and then check for the limit. So when you are evaluating the value of the sine 2n pi, it gives 0, it is multiplied, if you assume it is multiplied with 0 time n, it is always kind of 0, or it is, there is no n actually. So limit of this one means limit of 0 and goes to infinity, limit of 0 is going to be 0. That's the mean. To see that for what we have sequence, different type of sequences which approaching to the limit point where we want to find the limit of function. Okay, sometimes we are getting limit, sometimes we are not getting limit, but this if condition say for all sequence which is approaching to a, our function should approach to the where we are saying limit is exists, the limit is L. But our cases is different here. Sometimes we are getting limit, sometimes we are not getting limit. If I change with it by pi by 2, okay, some pi by 2 or minus something is there, okay, pi by 2, sometimes it is going to -1, and if you change with the there is one proper sequences, 1 upon n pi is gives you to 0, or 4n plus 1 pi. If we change, okay, I just erase it here, 2n pi, 2 pi n, 2n pi. If you check it for the sequence 4, okay, 4n plus 1 pi, and here is, or maybe pi by 2. If you check it for this sequence, it is also approaching to 0 because I just multiplied pi by 2 here. So if you substitute here, it is going to be 4n plus 1 pi by 2, which always gives you to which is always gives you to what it will give if you substitute here. I'm something missing for this sequence. I want to make it sine some sequences will give always 1. So I'm not getting it, that it may change sometime. It will vary. Yes. Okay. It will vary. For which, like if for pi by 2 and 3 pi by 2. No, not 3 pi by 2.
That will be -1.
That would be -1. 3, 4 pi by 2. For 4 pi by 2 it is going, no, 5 pi by 2, I think. Yeah. For 5 pi by 2 it is going to be, yeah, it will work. It will work here. If you substitute here 1, so it is going to be 5, and this is going to be 5 pi by 2. So it will work. It will give limit you as 1. Okay, it will give you 1 always. So see that for we have some sequences. Yes.
Sorry, so you're saying that because, is it because sine of 5 pi by 2, no, 2 by 5 pi, is that always, do we know those values? Sorry, I don't know, that's why I'm asking.
So actually it says 5 pi by 2 means it can be written as 2 pi plus pi by 2, I think. Yeah. So sine of 2 pi plus pi by 2 is, again, if you have this is the property of sine n 2n pi plus some a, it is going to be the sine a. This is the property of sine. So that's why it's give you to sine pi by 2, and this value have 1.
Okay, so do we need to know these values for solving?
No. I'm just telling you the definition. What's the mean of definition? Yeah, actually, it's needed when you do more practice. It will be make you comfort. If you know this, then it will make you always easier to do whenever you are not only for this course. If you have in suppose MLF also have some mathematics, in that maybe it will help you.
Sir, it will be easy to remember the 2 pi. Sorry, it will be easy to remember that 2 pi is a circle. So every time you cross 2 pi, you come back to the original position.
Yes. Actually, it work as this one.
Oh, it becomes 0. So sine of 0
At 0
is
is
0.
0 and pi by 2 is going to be 1. Like this, it is going to be -1. It is going to be, oh, this is going to be 0. Yeah, for pi it is going to be 0. It is 3 pi by 2. So at here -1, and again it is back to be 0. So whenever you are doing more time, it will see sign will only vary to here like this, like this.
Okay, sir. Okay. So these basic functions we should know, and we should also remember if we scroll a bit up, you had given the formula fn one function of 1 by h is equal to uh, it's up here only. It's sine
Sine 1 by x.
and
Sine
x
1,
itself is 1 by n.
sorry, 1 by x. Sorry, 1 by x we have, and we are trying to get the limit of it as x goes to 0. So as we check that, if we are saying the limit, we have these difficulties using the sequential approach we are getting.
Okay, sir. Because if I had to solve this question, and how I would start is that I would take fx is equal to sine 1 by x at x approaching 0. So the first value that I would put for x would be 0, and then it becomes 1 upon 0. So it becomes an issue.
So see, we know that this limit is not exist for this function.
Okay.
We know that this limit is not exist. Yeah, that's why I choose this function to tell you the exact definition what is happening here. I just choose this. Otherwise, there is no. You already know that as this is going to be one kind of 0. This portion is unknown. This inside, it is going to be a very large number 1 by 0, or not large number. This is infinity means we don't know.
Sir, but sine infinity, value of sine is between -1 and 1.
Yes.
So
but you don't know where exactly it is between.
Will it affect this, sir? Whether the value is becoming infinity, will it affect this function? Because
so you are not getting the limit as x approaches. You are getting a limit means you are, again let me tell you what do you mean by limit. So limit means what it mean. Suppose you are approaching to a number. Limit means you are approaching to this number. Your limit means there should be a point where you are, as you are walking around this point, your function value will also walk around some fixed point. This is called the limit. That's the mean of limit. As you are approaching to this means you are walking around this point, some substituting values, and you are getting whatever values you are substituting here. What is the output you are getting? What is going to be the corresponding output? So this says, I'm saying the limit of the function as x goes to L is x goes to a is L. That means output you will get around that L. As you wonder about this point around, you will get the value around this side, this somewhere here, as you change the value. That's the mean of limit.
Right. So thanks. But it's clear when it's not a composite function for me, and I'm able to understand, yes, x tends to a, so the limit approaches L. When it becomes a composite function, then it's different, is it? Because
so
then
when
we
it
have
is,
to see.
then when it is a composite function, then you have to be like first find the exact function composite after solving that composite, and then think about the function. What I mean to say, if you have sine log, if you want to sine log, so if you have this one, so suppose you have fx is equal to sine and gx is equal to log, and f of g is going to be sine log. So if you want to find the limit of it, so first solve this, find this expression, now think of the limit. So it is, sometimes it's like what is going to be limit is actually guessing that it is going to be difficult if you are approaching to some fixed point, maybe 0, not 0, because
maybe one we could take.
So no, I mean to say, okay, whatever we have. So I mean to say, first find the exact function and then talk about the limit of it.
Okay, but in this case, we would use the multiplication rule and then get the derivative, is it? So for example, it was sine log x. We would first apply multiplication rule and split it, then do.
For derivative, you will do that for getting derivative.
Not for this.
Okay, for indeterminate, for you are saying. For the case of indeterminate.
Sir, I'm not very sure the method, that sequential approach that you're telling, in that we won't do that way.
No.
How will we do?
So if you want to find the limit of it,
yes, sir.
At which point the question is at which point you want to find the limit of it?
X tends to 1, for example.
So x tends to 1 is yeah, so it is easy, right? Sine x, sorry, log is as x goes to 1, log, yeah, first log is going to be 1. Log x is going to be log 1.
Yeah, 0.
So as sine is also sine log x is there, as x goes to 1. So what is happening? Sine is also nicely behave for the log 1. Because you will get some real number. There is no
0.
issue.
Log 1 is 0.
See, where we want to find limit of it, there is something issue. Like here is we have some issue at 0.
Yeah.
But here is we don't have any issue, so just substituting value will work here.
So we know for sure limit is going to exist. We are not going to apply sequential approach here.
So whenever you have like difficulty to find the limit, so first we have to check that function limit of that function is exist or not. First we have to check. So checking for that is sequential approach. Then so once you got that okay limit is exist, then maybe it will work as just substituting values, or there are some other method also, or maybe this sequential approach also work to find the limit. Like whenever you are checking, you are getting L, right? So it will tell you, yeah, okay, limit is going to be L that for that function.
Okay, sir. Sure, sir. Thanks.
So what I mean to say, sir, talked about the sequential approach of limit. So what is this definition is tells about? So this is the mean we just talked about. So this is not for only particular. This should happen for all sequence which is converging to the where we want to find the limit of function, and then substitute in that, and that sequence, your function is now changed in the sequence form. Now that sequence have L limit, then we will say that function have limit L at that point. So this is the called a sequential approach, and this is we checked, we did this for the first variable. The same definition will work for the multivariable also, and I wrote this definition for multivariable. This definition is for multivariable. I just wrote because this see that this is the tilde here. I just wrote the same definition. This is actually the definition for multivariable. We check it for the single variable.
I have a question here. Maybe it's a little late to ask this question, but earlier when you said n is actually integer, where are we declaring that n is an integer? Because it is from real number to real number, that is going.
No, n here we are denoting means n is integer, means n is actually not only integer, it is going to be natural number, subset of natural.
Okay, natural numbers. But that is an assumption that we are making when solving this problem? Or?
Yeah, for the sequence, we have to assume, like we are talking about sequence, what is the domain of the sequence? Right. Domain of a sequence is always a natural number for any sequence I am saying. So you can think it as a not assumption. This is actually classified that okay, for sequence you are talking about, the sequences work on the natural number.
Okay. Thank you.
Okay, so this is the definition. I hope is it clear to you what is written here. So this is one approach. This is only one approach to discussing about a function have limit or not. Okay, and this is just saying to be, as you know, if you have two function add them, so what is going to be limit of it is just making to the separate thing. Okay, a separate means if you have addition function, then just make it separate. So let me tell you the another approach. This is called the sequential approach. Okay, the another approach is curve approach, and the curve approach is in this video. Then we will combine. This is actually whenever you are watching this two lecture 5 and 6. So first watch both watch, like first watch 4 and 5 also, then solve the both activity, not only one. Like if you watch the fourth lecture then solving activity, it is going to be tough for you. If you are watching 4 and then 5 and then solve the activity 4 and 5, and it will help you, like then you will get more clear about what is happening. So see that the another definitions are have written here. This curve approach, this is called curve approach. So curve approach is a very simple thing. So this is sequential is somewhat looking like a curve. Curve is simple thing, right? What is meant to be, let me relate to you. See, you are in calculus, first variable. So this is from R to R, right? And the limit saying to be limit as x goes to a. What is going to be limit of this function is, suppose L is, I'm assuming here limit of the function is existent, which is L here. So what is happening here? What is happening here? This is happening. We are, suppose we have a real line here, and suppose here is A. So we are approaching, this says x goes to A means we are approaching to A only these two sides, this side or this side. This side is called negative side or left hand side, and this is called positive side or approaching to the right hand side to A. We have these two sides, and whatever we are getting output, not output means where the function is, that means we are wandering around this point. Okay, we are wandering about around this point. So L is going to be, suppose here, so values will be wander, output will be wander around this side. That's the mean of limit. Okay, suppose you have value this one, suppose you want to find value of the function at this point. So this is give in this something is something is called open bound. Suppose in this around there is here, this at this point you are getting the value. If your point is here, so this will somewhere here, means you will wander around that exact L, around the L. That's the mean of limit, saying to be the limit of a function exists and L. So see that, so this is the meaning of the limit. Okay, and see we have only two sides. If you are approaching here means only either the point will be from this side will come to A or from this side. But now let's come to the here for multivariable. Let's assume for the single variable, let's store two variables. Suppose we have a function, some expression is given to you, and I want to find limit. Okay, let me make it here. So this is x-axis, this is y-axis. So we have two variables here as x and y. So some variable is, sorry, some expression is given. So we want to find the limit of function. Okay, so take a point. Okay, this tells you it will be a point in R2. So suppose here is the point, let's say AB. Okay, take a point from domain. I mean to say take a point from domain. So this is from R2 to R. Okay, this is from R2 to R. So take a point from domain. So domain is they have two coordinates, x1, x and y. So take a point from domain. Let's say this one. Okay. So we are approaching to this point. We want to find limit xy, now saying to be approaching to AB. Xy, now both variable approach to AB. What is going to be the limit of this function? Okay, this is the mean, this is the notation of it. Xy approaching to AB means we are approaching to the point A. Now what is going to be output here? See, output is only here real number. Okay, so it is will we work on some real number, out to out we are getting on real line. So as you are approaching, okay, so now here our approach is only from this side on line or this side line, but here we are have more space. We can approach this like this, like this, like this side, this. I see that here is only we are bounded two side, like here this one or this one, but here we have all around. This side is, we can approach to AB. We can approach to AB from all directions. See, that's the differences here. Or maybe see, so let me again tell you. Suppose we have point AB, okay. So we are approaching to AB, okay. We are approaching to AB as according to this line. According to this line, suppose we have a line here which pass through AB, which passes through AB. Okay, so we are approaching to AB according to this line. One thing can happen, or we have a curve which pass through AB. Okay, we have a curve, so we can approach to AB according to this curve also, like this. So I am telling you approaching, how we are approaching to AB. As here we are approaching according to the just line from left or right. But here are the, what are the possibility? We are approaching to according to this a line or according to the curve. That's the call curve of getting the limit according to the, that's the curve approach, sequential approach and curve approach. I told you. So we, that's the differences here. That's the, this is called, that's why this is called curve approach. We are approaching to AB according to this curve. So you have so many ways, like how, I don't know. See, there are so many curves which pass through AB, which pass through AB. I don't know what is the exact curve can be, but consider that all curve you have to approach AB means you are approaching to all possible curve what we have. Okay, so all possible curve you can approach to AB according to you. All possible curve is there. You can approach to accordingly. Let me mute. Okay, so this is the mean to approaching AB. Now, as we are approaching to OB, whatever the, again the, what is the limit? Limit is, see that our function is from R2 to R, so it will work only on this line. So we, whatever approach we are taking here, but your output only from either like this or like this. So this doesn't matter. This doesn't matter. I there is no left and right term. Means suppose your line is your output is a real number. So suppose here is your output. So whatever you are taking approach, your point will be somewhere you are rounding here. So output you will get rounding somewhere here. This is the mean. This is the mean. The main thing is how you are approaching here, and whatever you are getting limit, as you told you, this is only output is only a real line. So somewhere will be, suppose you are taking a point, you are approaching to AB, but you take a value suppose here. So your output will be somewhere here. If you are taking the point here, your output will be here somewhere. Like whatever the, so that's the mean of limit. That's the mean of limit. But the main thing is how you are approaching to this AB, where we are bounded only two sides, but here is, I don't know how many, like only this side not. The possible, according to the possible curve also we can approach. Let me give an example, then it may be more clear how we are approaching. See that. Suppose we have a function f of xy is equal to x upon x square plus y square. Okay, so this function is from R2 to R. Okay, now I just told you what is the limit when x is, what is the limit of this function at, okay, let me write here, limit xy goes to 0 0 f of x is exist. The question is, as xy approaching to 0 0 is exist or not, or if exist, what is the value here? So see that, let me make it picture here. So 0 0 means our 0 0 0 is here. So see, I can approach according to this axis itself, right? So according to this axis we are approaching means we are approaching to 0 0 like this.
x-axis. Yeah.
x0. If you suppose we are approaching to this side, okay, so this is going to be, we are approaching 0,
Y-axis.
0y and 0, 0. Suppose I am approaching, suppose I have given the line equation y is equal to some minus 2, yeah, so let's say this is 2x. Okay, suppose, so see that this line is also passed through origin. So I am approaching to 0 according to this line. So how it will be look like? It will look like, see that, how it will be, y is equal to 2x. So x and y is, we can write as 2x. We are approaching to 0, 0 according to this line. Suppose I am approaching according to this quadratic, this is called quadratic function, this is quadratic equation, right? Suppose this is y is equal to 3x square, right? So we can approach like this is also, we can approach according to this curve, right? This tells you a curve, this is not a line, this is now a curve. So it will be look like x is as it is and y can be written as 3x square. So we are approaching to according to this curve. So this is the, these are the differences. Let's say I'm approaching to with the I don't know, suppose this is the curve and I know that equation of this curve is, suppose mx square plus, no, not m square, this is going to be quadratic, so 3 mx cube plus nx square, some equation is given, plus c, suppose. So equation of this curve is, suppose we have, so I can approach according to this curve also. So what is going to be now approach is x is as it is and mx cube plus nx square plus c. So we are approaching to 0, 0 according to this curve. This is a so many turn, what is it? Tilde or what is the proper English? बहुत टेढ़ा मेढ़ा है this, ये ऐसे ऐसे जा रहा है in Hindi. So this is the approach. This way we are approaching. So now take approach like this is the approach. This is, that's why I call a curve approach. So what is differences here? So now the condition is what is the limit case. This is okay. We know about the approaching to point AB. Okay. So let me write again separating. So suppose you have a function. Okay. Now let's back to the limit case. Suppose we have a function. Okay. We want to find the limit of a function as x goes to AB. Okay. So AB is here. So we are approaching to AB. Okay. So the definition of limit is, so the definition of limit is whatever you are taking approach here, whatever you are taking approach, either this or this according to this curve or according to this line, whatever you are taking approach of to approaching to point this point, but for each approach, suppose you are going to along this line. Okay, you are, suppose you are going to along this line. So we have a function. Suppose we have equation of this this curve. Suppose equation of this curve is y is equal to some function of x, some function of x, as here this is some function of x. We are approaching to this point with respect to some function of x. So we can write, so as we writing here, so x with respect as we are approaching with according to this curve is cx f of x approaching to this point AB. So now as here we just this limit is can be written as limit xy goes to AB. What is this, is exist or not? This is question. So this limit can be changed as limit x, only x goes to A here, right? You can write x goes to A here. Now x could be, x is as it is, y can be written as this function x. Okay, see that y can be written as this function x. So if this limit is exist and is equal to some well, okay, so whatever you are like, what I am saying, whatever you are taking the approach, but for each time your function limit is exactly going to L here, then you will say this function had limit, sorry, this function has limit is exists for this function and it have limit L. Let me show the proper example here, then it may be more clear. The limit of function at A along the curve C exists and equal to L if for every sequence an contained in C which converges to A, the sequence Fn converging. So this is again a sequential approach, sir have given the definition. But if you see in the last, this is the same approach. Sequential is approach is means I will tell you what is happening there. Continuity. So here is limit f exists and equal to L precisely when for every curve C in the domain D passing through A, the limit of f at A along C exists and equal to 1. So this theorem, actually I told you this theorem, whatever you are taking approach to approaching, sorry, whatever you are taking the approach to approach AB, that function should also go to exact L. As you can see, limit of function at point 80 exists and L precisely when every curve C, whatever we are taking curve means whatever according to whatever curve we are approaching here, for every curve in the domain D, this all whatever approach is there, you can see that this is in R2. So whatever domain means your curve with lines will be lying in that domain or in that R2 passing through AB. So see that all curve we are taking all curve which passing through AB. All curve are passing through AB. Okay. The limit of f A till along C exists and equal to L. So whatever we are taking approach, this should happen. So sometime you are not exactly able to write y is equal to fx. It could be some implicit form. It could be some implicit form. Let's say xy is equal to some implicit form is how we can xy plus y square equal to, let's see. See, suppose we are approaching to AB according to this curve. So it is difficult to write y is equal to some function of x. But we are what I'm saying, if you are approaching to this according to this curve, still your function should approach to L as we are approaching according to this curve. So sometimes it is difficult to write exactly y is equal to fx, but still, if you are approaching along that curve, your function should approach to exact L. Then we will say that function have limit. I don't know, is it clear to all of you or what I discussed? Is it clear to all of you? Am I audible?
So the last part, xy plus y square is equal to c, that part, can you repeat, sir, please?
Yeah, I will repeat. But if you remove this portion, is it clear to what we just now discussed?
Previously, before that all I was so
is
clear.
it clear to all
Yeah,
of you?
yes.
I think also. So this portion, what I mean to say, okay, let me again write here. Suppose suppose this point is here and we are approaching to AB according to this curve. Okay. And according to this curve, so what is the equation of this curve? So let's say assume equation of this curve is xy plus y square is equal to some number, let's say 5. Just I said equation of this curve is this. So see that if you want to write y is equal to some, if you want to write this equation as y is equal to some function, y is equal to some fx, so it is difficult to write this one, right? It is difficult to write.
Yes.
But if you are suppose we are unable to write this one, but if we approach, so so writing like this is now it is difficult, but just visualize what I mean to say. Just visualize. If you are if you are approaching to AB according to this one, so your function should approach to L, should be approached to L if you are approaching according to this curve. So not only a particular, mean to say, suppose let me tell you now, if you the difference is, suppose we are approaching according to this curve. Okay, let's say y is equal to, we are able to write it here, y is equal to some function. Okay, if you are able to approach according to this curve, but your function now approaching to different limit L. I will give an example also. So if you are approaching to according to this curve, you are getting limit this. If you are approaching to this curve according to this, if you are approaching to AB according to this curve, you are getting different. In that case, your then you will say limit is not exist. It is not exist, because you are getting, as you are changing the curve, you are approaching to different way, you are getting different limit.
So you're trying to say that we need to think of the relation between y and x, which is going to give us different limits if in case we want to check whether
Limit is
all
exist or
functions,
not.
yeah, all will give the same limit or not. So it's because we need to find, we're not always going to get using the along the x-axis, along the y-axis will not may give the same result, but now we have to find an example where it will not give that same L. So how do we find that? We think of some relation. Is that what you're saying? So what I assumed from the lecture was only three things to try. One is along the x-axis, along the y-axis, and y is equal to x or y is equal to mx. But are you saying there may be all these three may give L, but there may be something else which will not give L, and that also needs to be considered. Is that what you're saying?
Yes, exactly.
So then, okay, sir. So then, that fourth thing, how will we figure out, sir?
So let me tell you. So now tell me with the example. Maybe now it is clear to you. So suppose suppose we have function xy is equal to x square y upon x to the power 4 plus y to the power 4. Suppose we have a function this, and we want to check it limit as xy goes to 0 is exist or not. Okay, so if you check, if you are approaching to 0 according to this line, so this is x, this is y, so it will be what, x0, right? Approaching to 0 according to this axis, according to this line, so it means x and 0 approaching to 0. Now substitute here. Now we want to check it here, so we can write this one as limit x only goes to 0, because as you are putting the value y is equal to 0 itself. So that means here your x square times 0 upon x to the power 4 plus 0. So it gives you 0. Limit is going to be 0. Now if you take with this side, also will give you 0. This side is going to be this, according to this line is going to be 0 y. Right? According to this line, you will approach like this. Suppose I am approaching now with this line to 0. Suppose this equation of this line is y is equal to, just assume a straight line is there, y is equal to mx. So now according to this line we are approaching, let me note to you. Okay, so it is now going to be x and y is equal to mx, so this is mx. So you are approaching to 0 according to this line. I don't know exactly what m, but let's assume this is m and y is equal to mx. Now substitute in that equation. So x is as it is, x square, sorry, and y is mx here. So mx upon x to the power 4 plus y is exactly mx. So this is going to be 4. Now this is x cube into 1 plus m here. Sorry. This is m x cube. Sorry, mx cube. Now take x power 4 common, so it is going to be 1 plus m to the power 4. So your limit is now how it is will be look like as xy goes to 0 means x now only you have x variable, so x approaching to 0, m x cube upon x to the power 4 1 plus m to the power 4. You can cancel out here x m power 4. See that now if you want to take the limit of it, it is not exist. You have out and in denominator x, here is x in denominator itself. If you substitute here now value is going to be infinite.
Yes.
Now if it like this is again saying like see that if you are approaching according to this axis, okay, you are getting 0 limit. If you are approaching according to this axis or this line, getting 0, but when you are approaching according to this line, you don't have limit. In that case,
So,
you will say this function don't have limit as x y approaching to 0.
so up to 3, we know how to try, but can there be, were you explaining a case when all these 3 will exist and then we have to think of something
So
else?
let's assume let me I am approaching to 0 0 according to this line, y is equal to mx square. I don't know, some is quadratic equation is there according to this
Okay.
quadratic curve. So what is going to be now here x square, and so your approach is x and mx square you are approaching, y is equal to mx square, okay, to 0 0. So in geometrically it will be look like approaching to 0 according to this quadratic curve. You are approaching to according to this curve. So now substitute the value here. So your limit xy goes to 0 0, f of xy, this is going to be now changed to only one variable. X goes to 0, x square, y is your actually mx square. And now here this is x to the power 4 plus m. Now let me change the function here. Suppose your function is, then it will be more clear. Suppose your function is this one, x square y upon x square plus x to the power 4 y square only. Then it will be clear, more clear to you. Suppose your function is now this one. Whatever we did above, suppose your function is now this one. So now this is, if you substitute here, this is the same in numerator, it will give the same. In denominator, now it is going to be m square x to the power 4, because you are substituting y is equal to mx square. Now take x square common, and then x to the power 4 in numerator, denominator you can cancel out. You finally will get limit as x goes to 0, 1 plus m square. So there is no x variable, so limit is going to be 1 plus m square. Limit, this limit is now m plus, m upon 1 plus m square. So what it means is, so see you that you have this quadratic y is equal to mx square. If you assume m is equal to 1, so suppose your quadratic equation is this one, y is equal to m is equal to 1, then your quadratic is y is equal to x square. M is equal to 2, it is going to be this curve. M is equal to 3, it is going to be this one. Okay. So as you are changing the curve, your limit is here. As suppose m is equal to 1, your limit is going to be 1 plus 1. As m is equal to 2, now your limit is, this is the final limit, right? Just substitute here also m is equal to that. So you are going to be 1 plus 2 upon, some number will come, some different number, 2 upon 1 plus 2 to the power 2 to the power 2. This is now for this, as you are approaching according to this curve, suppose this is y is equal to x square. As you are approaching to this, you are getting different limit, this one. This is y is equal to x square. If you are approaching, it will give a this limit. Similarly, if you change the curve, it will give you a different limit. But when you are saying limit is exist, for all cases, it should be exactly a exact number. It will not different.
Okay, sir.
So is it clear to all of you what I'm saying, what I mean to say?
Yes, sir. I was only thinking mathematically earlier, so I would have thought, okay, third case we did y is equal to mx. It did not exist, so I'll
Just
stop
assume
and
like it may be like y is
yeah,
equal to mx
yeah.
square. Let me tell you some path also. Like for 0, 0, maybe it could be y is equal to mx cube, or maybe let's assume y is equal to x square plus 2x plus, oh, maybe this curve. This is also approach to 0, right? According to
Yeah.
this curve, you will approach. So it's up to you how you are approaching. So this will actually help you to find whenever limit is not exist. It will tell you, okay, limit is not exist for that function. So this
Excuse
is
me,
the,
sir, there are many ways to prove that limit does not exist, right? Is there any way to prove that limit exists?
so let me now tell you. So this is the way to telling you that limit is exist. So only we for this course we have only the sandwich theorem, sandwich theorem, which tells you to find the limit only. We have only one tool. Okay, another tool is just substitute the value. Another tool we have, if suppose your function is f of xy is equal to x cube plus xy. This is the simple function. So limit as xy goes to 1 to, what is going to be limit of this function is just substituting the value.
Sir, for some cases, substitution does not work, right?
So for some cases,
Piecewise
substitution
functions will be there,
is,
where the function is not defined at 0, 0 or some values.
so substitution we have one tool. The another tool is only we have sandwich. WITCH, or maybe yeah, sandwich. So we have another tool is sandwich. So what is sandwich again? Sandwich is a very sandwich. I hope you've gone through the calculus portion. Sandwich is, what is sandwich says? Suppose, okay, suppose we have a function R2. Sorry, in calculus I'm just saying for one variable. Suppose we have function R2R, okay, and we want to find the limit of this function as x goes to a, yeah. What is of limit? But you are lucky. I'm saying just now I'm using the word you are lucky. And what is that luck? Luck is that your function is like this. Suppose you are able to get two functions such that for all x in the domain. You are lucky and you are able to get two functions such that this is happening. What it mean that? Let me, means your function, like suppose this is in geometrically, let's suppose your function is f is this one, okay. So you are able to get two function f and g, sorry, h and g. So g is less than here, so g is below to that, and h is greater, so h is greater. So your function is lie for the all domain. Let's assume this is happening. This is the representation of this inequality, because your f is lying in these two values, in these two, between these two functions. Okay, so now you are lucky to get such function h and g, and you are able to, and also again the word I'm using, lucky. Okay, so you are able to get limit as x is approaching to a. X is also approaching to a, and you are able to get limit L, suppose exactly L for this H also, and sorry, G also and L also. Means as X is approaching to a, you are able to get limit of H is L, and again X is approaching to the limit a, you are able to get the same limit also, not L prime. These two are not going to different, the same limit. Then sandwich says this will also go to L. This is the definition. When x goes to a, here we have already want to find the limit of it of f. This is the sandwich theorem. The reason also I can tell you in the geometric way also, as x is approaching to a, okay, from this side as x is approaching to a. See that what is happening here. So okay, let me write here. And suppose your f is this one, okay, and your g is like this. Okay, again it is back to here. Still your f is like this. And what is happening here? Your h is like this and back to here. So this is your h, this is your f in between, and this is your g. And suppose you have a here. So what is happening here? Again, the same condition follows this representation. F is lying in between g and h. So as you are approaching to a, your what is happening here? Your f is also approaching to, suppose this is L here, approaching to this L. Yeah, g is also approaching to L. F is h is also approaching to L. So the sandwich says then f will also approach to L. And also geometrically you can see also this is happening. This is happening. This is the sandwich theorem in geometric way, if you will say.
So will it always be easy to understand that F lies between G and H?
No, so that's why I said. So you are lucky. You are able to get H and G.
How can we try that, sir? I mean, if functions are very simple, by looking at them, we'll understand.
Then you can give easily. But sometimes, yeah, it is not easy. But you have, so from the whatever you have function is given, from this function you have to manipulate. So let me give an example, then you will see that how
Yes,
we
sir.
will manipulate.
Yes.
So one example we have in this, I think, fourth lecture. In this activity, we have one question. This one, the third one. We have a function. This is, you can say, piecewise. We have, what is that function? F of xy is equal to 4x square y square upon x square plus y square when x and y are not 0 simultaneously and 0 when both are 0. Suppose we have this function and this question is asking what is going to be limit as xy goes to 0, 0. So how do we find this limit? If you substitute here 0, 0, you will get 0 by 0 form.
Hello?
So it is going to
Hello?
be difficult. Oh, let me mute this. Okay, so substitution is not working here. So how do we find now? Only one tool is remain now. Substitution is doesn't work. Sandwich now is remain. Only the second tool we have, sandwich. This is now is failed here. Then other now we have sandwich. So how we will approach? How we will apply here? This is also difficult to find. How we will find G and H here. So we have to do something.
Sorry, before we do that, can I ask one question, sir? As per the definition of the function, we should not substitute 0, right? Because it's not defined at 0. Or I didn't understand, sir.
No, actually, so it is defined. Function is defined at 0, 0. We have 0.
It's, yeah, that particular substitution is not defined at 0. So the function is defined to be 0 at 0, 0.
Yes.
Yeah. Okay.
So whenever we are approaching, we are doing this approach, the substituting approach. This one, using this approach, we are, if you want to find 0 limit and just substitute it, we are not getting the limit.
Okay. Okay, sir.
So it means to say this is just approach. This is just a way to, okay, we are substituting, we are not able to get. The second now remain to sandwich. So how do we apply sandwich? How do we find, again, this is our F. So how we will find H and G satisfying this and something we have 0, 0. Like how we will find this F and G. So see that there is one thing in this function, this property, there is one property in this function. This is always going to be positive, right? Because all are square.
Yeah.
The value is of this function is always going to be positive. So one thing we have, this f is always greater than 0, greater or equal to 0. So what we can do, we can assume gxy is equal to 0, right? We can assume. So I just told you this for the one variable. Okay, I just told you for this one variable. The same definition, there is no differences. The same definition will work for the multivariable also. So let me write also. I just started doing the question. Suppose your function is scalar value, this function is this one, and this condition hold h and g, where h is also a function, where h is also from Rn to R and g is also. So let me write here g, h, all are from R to Rn to R, and we want to find limit of this function as xy goes to ab. So suppose we have able to find g and h like this, and this this is limit of this function is L when xy is going to be ab, and this is also L when xy goes to ab, then this is going to be L also. So this is the same, this is for Rn I wrote, no, I just make it for R2. So for R2 this will work, for Rn also the same definition. How many variables is there, your g and h accordingly will change, contain that much variable, and same the definition. In the definition or maybe in theorem itself there is no differences, only the number of variables are different according to which space you are taking. Okay, so as here, let's back to our this question. So this function is always going to be greater than 0. So we have one tool. We can assume g of xy is equal to 0, 0. Only remain to now find h. So see that what is the property of this function? As xy going to be 0, 0, limit of this function is also be 0. So one we are able to get g. Now remain to find h. So how we will find h? So suppose this is we have this function. This is f over x square plus y square. What we can do it here? Let's break these functions in some form. So what I mean to say, x square is always less than or equal to this. What I mean to say, x square is we can say less than or equal to x square itself, or if we add a positive number. So let's assume we are adding here x square plus y square. So this is always true for all x and y belongs to R2, because this is the same number here, but just a small number, some extra number we are adding here. So this is going to be true for all x and y. So one thing extra we can do, this inequality can be changed now in this form. X square upon x square plus y square is less than 1 for all x, y belongs to R2 minus, only you can remove 0, 0. At 0, 0 this function is not defined, but rest all are, this inequality is going to go, because whatever we have and some extra number we added here, right? So this is going to be true for all element of R2, only 0 except from 0, 0. Okay, so what we can do now? So x square is going to be less than, sorry, x square plus y square upon, sorry, x square upon x square plus y square is going to be less than for all xy belongs to R2. You can remove only 0, 0 vector. Okay, now see that what we can do. Let me write the step. Maybe you will get. What I can do, I can multiply both sides with x square y square. This is going to be, I just multiplied both sides with x square, sorry, 4x 4y square. So 4y square I both side multiplied. So still this inequality is not, it is not going to be changed for all x and y belongs to R2 minus 0, 0. Still it will work, because whatever we have, just multiply. Whatever we have inequality, with positive number we are multiplying, not with the negative, because 4y square is actually positive. So the inequality will not affect, it will be changed like this. There is no effect on inequality. Please be consider with you are multiplying with the positive. If you multiply with the minus, now it is going to be changed. But we are lucky that our function is nicely defined. That's why we are able to do all. So see that this is now f. This is our exactly f. So you can assume your h is 4y square. H is actually 4y square. So there is not luck. Actually, we have to. I just always said that we are lucky. You are lucky, but there is no luck. Actually, we have to construct G and H. As you can see, I just constructed G here. Now what we are doing, I just constructed here H. So not luck, actually we are constructing here. Now see that this H of this function H is, as xy goes to 0, 0, this is going to be 0. There is no x, so still it will work. We are able to find the limit of it, and it will goes to 0. H is goes to h of xy will go to 0, 0. So see that we want to find limit as xy goes to 0. So see that it will work for all. So this inequality now, 0 less than 4x square y square upon x square plus y square 4y square. This is inequality is true for all xy belongs to R2 minus 0, 0. Right? So now as xy goes to 0, 0, this will go to 0, this will go to 0. So what it means that we want to find the limit of it. This will go to 0. This is the sandwich theorem tells you. Clear? So now we are able to find the limit of this function. Actually, it is now 0, 0. Sorry, 0. So I don't know, is it clear to all of you what I just want to tell you? Limit this.
So, I have a doubt, sir. I haven't solved the activity question, so I'll maybe it will get cleared if I solve one. But could you please clarify, sir? What we did here was we found for the gx and the hx which are complying with the that when xy tends to 0, 0, then the function goes to 0. So, what kind of questions will come related to this, sir? We'll have to find gx hx, or we'll have to gx hx will be given, and we'll have to say whether the
No,
limit
so
for
see, this G and H is not unique. So if the question is asked, it may be difficult to it is asked in option. Like in calculus portion, you have seen that one question is the math one. There is one question to find G and H, but generally used to ask the limit of it, and
okay.
always finding too difficult. Like whatever we previously did, the curve approach and sequential approach, these two approach, this tells you the non-existence of limit. But the remain thing is either you will substitute or either you will do with the sequential approach, sandwich approach, then you are able to find the limit. So this
So
is
in
the
the
only
question,
in the
okay,
question it will ask you to find the limit of the function.
when gh and hx, g and
No,
h are
not
given.
necessarily. It is not is necessarily given. You have to find G and change, and you have to find the limit of anyhow. However you are able to find, you have to find that.
Okay, okay, sir. So we will think of two functions where we can get the limit, and using sandwich principle as understand f lies between g and h, and that's why the limit for f is same as g and h.
Yes.
Okay, okay, sir.
That's the sandwich theorem, and that's the all about the limit now. Limit of a function is done. This is the only tool. This is the only major tool to give you the limit of this of a multivariable
Thanks.
function. Now the only rest part is that's all about the limit of. Now the continuity part is same. So continuity is the same if the limit of the function as xy goes to some ab, f of y we have is exactly value at that point, then we will say this function is going to be continuous. That's the definition. Continuous stern answer. If the function value is exactly the limit value. So what is the in the if you will say what is difficulty in the continuity? Only the limit. If you are able to evaluate limit and if you check that exactly the same value, if the function value is same as limit value, then you will say the function is continuous. The next part is if you talk about the partial derivative is continuous or not. Partial derivative means first find the partial derivative. Okay, it is going to be some function. Is going to be some function. So limit at that point of the partial derivative, it should be exactly equal to the value of the partial derivative at that point. That's about the continuity of the partial derivative. Continuity of partial derivative. This is for the partial derivative with respect to x. Partial derivative with respect to y is the same. You can change x with the y with respect to this is x. So if it contain more variable, so partial derivative with if you partial derivative, suppose this function contains x1 to xn variable, so partial derivative with respect to xi variable is said to be continuous at point x1 to x1 approaches to a1 to an. Okay, is said to be continuous if exactly the partial derivative value of partial derivative at that point is limit is exactly the same as of the partial derivative of limit of the partial derivative. This is all about. There is no differences of the continuity. The same definition as you did for the partial derivative or a partial continuity of the partial derivative. That's all. That's the finishing to be this lecture. This 5-4 is done. Continuity is one portion, value of the function. Continuity is one condition. Limit should be equal to value of the function. So only the last part is remain gradient. So let me tell you the gradient. This will end the our week.
Excuse me, sir. What are the necessary conditions for partial derivative to exist?
To exist?
Yes, sir.
There is no necessary condition. You have to always check using the limit definition, or maybe you are able to used to do with the assuming as a y constant as x as a variable kind of. There is no condition. Let me check one. Let me check 1 minute. If there is condition.
I mean, can we conclude anything? If the partial derivative exists, can we conclude anything like limit exists or so? You got my doubt now, sir.
Yeah, actually, yeah, I'm getting your. If the partial derivative exists and continuous, then we can say that limit is exist or not. So yeah, there is one condition. Let me search. So there is one condition. Just 1 minute. This time I'm not getting this one. For the differentiability, we have for existence of limit, we don't have any condition that if the partial derivative exists and continuous, then we can say limit is exists at that point. I'm not sure. Actually, it is not tells you that. So actually, there is no relation saying to be if the partial derivative exists. Okay, the both partial
Yes, sir.
derivative exist. Okay, and okay, just 1 minute, just 1 minute. You can relate with the differentiability.
So it is not necessary to have the limit well defined for the definition of partial derivative. Am I right, sir?
Yeah. So actually, you can tell that if you partial derivatives exist and continuous, okay, both partial derivative
Yes, sir.
of how many variables is contained. If both partial derivative, if both partial derivative exist and continuous, okay, then we can say limit is exist at that point. Yeah, actually there is one condition.
Okay, sir. Thank you, sir.
So actually it doesn't tell only the limit. It actually tells you one more condition. It tells you that function is differentiable, not only continuous. Function is differentiable also. And this theorem this is one theorem. This is some specific theorem name is there. So if partial derivative exists and continuous, then we can say your limit is not only exist, your function is actually differentiable with at that point. And once you have function is differentiable, what it means that in one variable you have seen, if function is differentiable, then function is going to be continuous. And if function is going to be continuous, then limit is exist.
Okay, sir.
Even
So that's
for sir, even for gradient vector function, no, sir has told if all partial derivatives of f exist, then
and
the gradient vector is the combination of those
not
partial
only
all the
exist, not only exists, sir told about the continuity of it.
for continuity he talked about directional derivatives. So he said if it exists and continuous, then for every vector the directional derivative exists. For gradient vector he said if partial derivative exists, then gradient vector exists. I'm not sure if I understood
Okay,
correctly.
let me see that. Yeah, there actually one theorem in that this one, right?
Yes,
If it is if suppose this is exist and continuous or some moving variant, then the directional derivative exists. Sorry,
Previous to
directional.
this, yeah, this is when it is existing and continuous. But before that, in the same lecture he has told if suppose all partial derivatives exist, then the gradient vector is a combination of those. So they need to exist for making the gradient vector, I guess.
Existing for the gradient is the okay. Yeah, so existing for the gradient is gradient will exist. Yeah, correct. Gradient will exist. For the directional derivative, it should be continuous. Yeah, correct. You are correct. Yes. So existence of gradient is not much like why you are evaluating the value. Why you are getting this gradient is only for the directional derivative for this course only. Yeah, but there are some more uses. But for this course only, we are use the gradient for the directional derivative. Okay. So for this, okay. So for this, so let me tell you what is that gradient first. Then we can discuss this theorem also. So suppose you have a function from Rn to R, a scalar valued function. So gradient, this is called gradient of f. This is called nebula. Nebula, something is named. Nebula is in pronunciation, I know. Nebula, yeah, Nepal, nebula, nebula, yeah. So this is called nebula. So this actually you can think this is an operator. Operator means it will when you operate this function will convert to some in this form. How many partial derivatives we have? actually this operator is actually convert this function to in the vector valued function. This is one kind of vector valued function, right? So maybe a vector valued, it maybe you will look like very difficult thing. So let me change that word. This, when you apply on this nebula, apply on the a function, it will be, will give you to this one. These are the partial derivative with respect to one by one variables from 1 to 10. So suppose we have a function f of xy is equal to x square plus 3x plus 2xy plus 5 y square. So once you apply this operator, this is called gradient. So the whole thing is called gradient of f. Single one is called nebula, and this is one kind of, you are applying this operator on f. So gradient of this function, the proper word saying to be for this course is gradient of function f is just find the partial derivative of it and make it as comma wise, means coordinate wise. So this is going to be partial derivative of x is 2x plus 3 plus
Plus
2y.
y.
That's all. This is going to be 0. And fy is going to be 2x
X
10y. So your gradient of this function will be 2x plus 2y plus 3 comma 2x plus 10y. So this is that's all about the gradient. So what is the use of this gradient? Why we are trying to find it? So gradient is actually will help you find the directional derivative of the function. So what is the question here? If suppose your question is like this, okay, suppose we have a function fx is equal to the same function from R2 to R, okay, it's defined as above, we just discussed this one, whatever we have, we define like that. So the question is, suppose we have function defined like that, find the directional derivative at point, let's say 1 2 in direction of 1 1. Surely in direction, the question, in the question given direction, it will be in unit vector. So in the direction of this. So how you will find this? So first find the gradient of the function. So gradient of the function we have already, gradient of the function at that point. At that point we have, so let's say this is AB. We want to find at point AB at point. This is point and this is direction. Find the gradient at that point of the function. So substitute just values here. So this is going to be 2 into 1 plus 2 into 2 plus 3. This gives you to 7 to 9. And this is 2 into 1 plus 2 into, sorry, 2 into 10 into 2. This is going to be 20. And this is 22. So gradient of the function at point 1 2 is 9 and 22. Now the directional derivative. So what is, how we are writing directional derivative, means d in the direction of that of the function f at point 1 2 is just the dot product of these two. So dot product is now going to be a real number. So this is 9 plus 22 upon 2. So 31 upon 2. So this is the, like, using that bigger limit definition. What is that? Limit h tending to 0. Another way is that using this limit form you can do limit h tending to 0 f of 1 2 plus h 1 upon root 2 1 upon root 2 minus value at that point upon h. Using this expression, you will find the same value, or directly using the gradient you can find. But the condition is, your gradient should be So this is the theorem what we have. If you want to apply the gradient to find directional derivative, so this is the theorem. The partial derivative should be exist, not only exist, should be continuous. So see that this partial derivative is as a polynomial. These are the simple polynomials. So this is going to be continuous. Polynomials are continuous, not only continuous. These are the differentiable functions. So for these are the continuous for this. So if you want to check it here, so the same process you will do. You have to find the like what we just now the continuity discussed. This one derivative continuity of the partial derivative. We have to do that. Otherwise, if you know that okay, these are the just a polynomial, so you can okay polynomials are continuous. Just substitute value and get that. So that's all about. And this is behind the region sir is telling what is why this is happening, why this exactly we will this find this form, this gradient at that point and that direction. This is just sir just proving that like that's all the video. So that's all for in this week. So you can now if you have doubt you can ask whatever we discussed. If you have still in that you can also. Otherwise, whatever in this week have concepts with those we totally discussed. See that in the whole in this session the only main thing was limit. Once you find the limit, then with the continuity, then with the gradient. Okay, that's all for. So if you have doubt, you can ask, or we can stop the session also. If you have doubt, you want to solve, you can ask. That we can stop the session also.
So will there be a solve with us session also for week 9 or already you were not sure?
So which date do we have?
Oh, if there is already a plan, sir.
Let me. This is going to be generally on Tuesday, right? Oh, sorry, Wednesday. No, Tuesday.
Okay.
Yeah. So actually, there will be session.
Okay, sir. Thank you, sir. I think that will be also helpful. But the concepts are now they're all, sir. They seem to be all related. It seems that every lecture is talking about the same thing. So it will take some time, I think.
Now, if you watch the lectures, maybe very much it will be clear to you, sir, what is talking, what is happening. The
Okay, sir.
Lecture wise, we gone and we discussed.
Yes.
Could you please do for me an example what sir taught in the video? I think 9.4.
9.4.
Yes.
Okay.
Directional derivatives, product rule, and the quotient rule. After quotient rule, he gave 3 examples. The third one is about sine xy. Again, the trigonometric function.
Oh, which lecture? Okay, let's see that. What is that? Which 9.4? No.
I think 9.4 it is.
It is talking about directional derivative. Sir,
Yes, sir. Yes, sir.
so it may be in 9.3 because
that properties, linearity and products, then product rule, then quotient rule he explained.
Okay.
Yeah, this one.
Okay, so
The third one, fxy is that sine xy.
what we discussed. So, okay, product rule. Yes, this one.
Yes, sir.
So what is doubt here?
Sir, I didn't understand that how he find out the limit of sine xy.
Okay, so this quotient rule, let me write here. See that what is happening here. If you want to find the directional derivative, So what is here is find the directional derivative of f at that point multiplied just value of g at that point minus value of f at that point and directional derivative of g at that point
Yes.
and divided with the
G of L. Yes.
divided with the g value of g at that point of square of it.
Yes.
That's
The last portion we took do from ourselves that I couldn't get.
so where is the last portion is what here?
That examples are the next part. F of xy z is equal to sine xy. That examples, the
Oh,
three
in example.
Yeah,
This,
the last, that one.
okay,
The
okay.
last.
Example. Okay.
I got sine xy of some very big this thing. Then how can we conclude to that final
Okay.
answer?
So what is happening, sir, is what is doing there. Okay. So sir didn't complete it, just wrote.
Yeah.
Okay.
Then how to get the zero and I don't know.
Okay. Okay. So this is for in this question, sir, what is trying to find directional derivative.
Yes, sir.
Yeah. Okay. So let's see that. Okay. See that. Okay. Let's see that what will happen. We have sine x y. Sorry, sine x into y.
xy.
So in the direction, sir has generally taken u1, u2. Okay,
U1,
in u is equal to. So and sir is talking about the general case, not at a particular point. Xy has sir have took, sir have taken. So this is okay limit. So directional derivative, direction of u of the function at point xy itself is written as limit. So if sir is just writing with the f u, if you okay with that, I just wrote it d. So don't get confusion. Sir used to be write like that. I am just writing with d with the suffix u. So limit h tending to 0 sine. Okay, this is xy plus h time
Times u1, u2
u1 u2
minus
minus xy upon h. This is going to be sine x plus hu1
1 into y plus h2.
comma y plus hu2 minus sine xy.
Yes.
So this is exactly equal to the substitute. Sine I am writing. Oh, I am missing. I am doing mistake here. This is going to be f. F. Then we substitute values, right?
Yeah. Sine of.
This is f here. Now it is going to be sine x plus h u1 into y
plus
hu2
minus sine xy
sine xy.
divided by h.
So okay. Now so what
Product I got.
it's going to be
Yeah. Then how will get zero? Some part it becomes zero. How it will get zero? That I didn't understand.
so it is sine xy cos this one. Okay, cos xy. Okay, so
Till that much I got, sir. Sir, because sine xy into cos hu2 plus yhu3 plus h square u1 u2. That I got, and cos of xy into sine of the same expression will come.
so first
That
you have to
one I
multi.
got.
Okay, so what you are doing? You are first multiplying it. Okay.
How to take the limit of that one? That is
So,
the
so my question is how you are writing this. You are first multiplying. Okay.
yeah
X
sine
plus y plus x
cos
h u2 plus
yeah
h
y
over y time y h u1
u1 plus
plus
h square u1 u2.
u2. Okay. sine xy.
Yeah.
Now what is upon it? So now what you are doing, or sir is doing?
Yeah, I think we need to take the derivative, no?
No. Here is not derivative.
So I didn't understand.
Here sir is not taking derivative. Sir is applying sine a plus b.
B.
This could be
Okay,
written
sir.
sine a cos
A
b
supposed
plus
B plus
cos a sine b.
B. Yes, sir. Yeah.
Is it correct?
Yeah, that will be.
So this is going to be sine xy cos x hu2 plus
Yes.
y hu1 plus h square u1 u2. I think
Right.
there is.
Yeah.
And then plus cos xy sine is going to be that bigger expression minus
Minus
sine xy
sin x.
upon it.
We can take sin xy common.
Now sine xy you can take common here. So it is going to be cos that bigger expression. Okay.
Yes, sir. Minus 1.
Plus cos, sorry, minus 1. Minus 1 plus cos will be as it is out. Let's make it cos as it is xy and
Into sine bigger expression by h.
Upon.
Yes.
Okay. Now what we can do?
We need to take the limits.
Okay. Now we meant to take limit. Okay. So then after what we can do here? Here is h each time. We can take h as common.
Okay.
No, so no need to take. You are taking common here. Sir is not doing.
No, I don't know, sir. After that,
okay, so no need to take common here. So it will be difficult to take common.
Yeah.
What we can do? So we will not take common here. Otherwise, it is difficult to. It will be difficult to solve. So what is that? Now we can do. Here is okay. For this, we have to take common. For this, we don't. No need. Okay. Okay. For this, we have to take common. So cos with this bigger expression minus 1. So what we can do, we can make it separate here upon h.
Yeah.
Plus cos xy
sine
that bigger expression upon h.
Yes. Like that.
Now we have to take limit.
Limit, yeah.
So see that now this is limit in one variable, and now this is going to be indeterminate form. How is going to be? Can you tell me?
Because denominator h came.
So see that in this h we are taking this limit only. We have whatever x u we know these are not varying. Only we are taking limit with respect to h.
Yes.
And how we are able to? We are getting indeterminate form. See this. What is this expression? This expression is cos x h u2 plus y h u1 plus h square u1 u2 minus 1 upon h. So if you substitute here 0, how to check determinant means you substitute here 0. So this is going to be cos 0. So cos 0 is 0. Sorry, cos 0 is 1. Cos 0 is 1. So 1 minus 1 is going to be 0 upon, we have already 0. So this is, see that this is going to be 0 by 0 form.
Yeah.
So now we have to do that L'Hospital rule we have to apply here. So if you apply L'Hospital rule, or that is called L'Hospital rule also. If you apply L'Hospital rule, so you have to derivate this whole function in denominator and with respect to h. With respect to which function? With respect to which which respect to h, because we are taking this limit with respect to h.
Okay, sir.
So if you derivate this is now is going to be sine. Because cos is derivative of sine is going to be cos.
Yes, sir.
Cos with this bigger expression minus 0. Derivative of this one is 0 upon derivative of h is 1. What you got? Minus sine that bigger expression. Only this portion we are solving. Only this portion.
Okay, sir.
So now apply limit one by one. What is going to be limit of this portion?
Sine xy.
Sine, it is going to be 0 because this bigger expression
Yeah,
gives to be 0.
yeah,
The whole
0,
expression limit is going to be 0.
0, yeah, this part.
And similarly, what is going to be here? This is something, okay, let me now tell you the here expression. We have cos xy. Sine, that bigger expression is
Yeah,
this one.
yeah,
You can
same.
take h as a common. So what is
Yeah.
going to be here? H, okay, x u2 plus y u1 plus h u1 u2
Okay.
upon h,
Yes.
the whole h. This is whole
Yes,
h.
sir.
You want to
Yes.
find the limit. You have made it separate limit here.
Yes, sir.
Limit here.
Yes, sir. That is clear.
Okay. So now what is that? This, there is no h, so we no need to worry with this one. We have to worry with this portion.
Yes, sir. Second.
So multiply in denominator with x u2 plus u2 plus y u1 plus h u1 u2, and also in numerator multiply with that expression, removing this portion,
Yes.
this one only we are multiplying. So
Yes, sir.
function is how your function is becoming here. Sine, see this, now your limit is here. What is happening? Sine x goes to 0, sine x by x kind of,
Oh, okay, sir.
right? This is
Yeah.
going to have that kind of. And what is the limit of this?
Sine x by x is 1.
1.
Yeah.
So you have in this expression, you have x u2 plus y u1 plus h u1 u2.
Yes, sir.
You will apply here limit also. So this gives you h u1 plus h u2 plus y u1 only.
Yes, sir.
So final thing, this term's limit is cos xy into x u2 plus y u1. This is the limit of this second term, and the first term is limit is 0. So the
Yes.
directional derivative in the direction of that is going to be this one.
Okay, only the h part get 0, the second portion. Okay, now I understood. Thank you.
Is it clear? Actually, this is a
Actually, this is the last term's portion. I was
actually this is I also thought maybe it is going to be tougher, but slowly
Yes.
we reach the answer.
Yes, sir. Thank you, sir.
Okay, I all of you got right. All of you also. This what we solved. If you don't get that, please let me know again. I will tell you. I will repeat it again.
Can you explain? Can you scroll up a little bit, please? Yeah. Where you actually said L'Hopital's rule is applicable, that portion onwards, I mean, why are we actually not concluding that 0 by 0 on it is 0? Why do we need to go for L'Hopital's rule? Can you actually?
The reason is we are getting this limit, this limit as a 0 by 0 form.
Correct.
So in that situation, we have to go L'Hopital rule, right?
Yes, sir. Last time.
Okay.
If we go L'Hopital rule, so we have to derivate this portion with respect to L'Hopital rule be applied with respect to that variable. We have to derivate with respect to that variable.
Okay.
Here we are so many variable, but here we are try to get the limit with respect to h only. So we have to derivate with respect to h only.
Okay. When you are doing the derivation with h, cos converts to minus sign, that is okay, but interior of the bracket, that is not differentiated the second time, is it?
No. So, okay, cos is going to be okay. Cos is going to be that one. Interior also going to be derivative. I think I missed that. So if you multiply that with that after the derivative, still the answer will be the same. We didn't get the wrong answer, but this is going to be 0. So whole thing is now going to be 0 because this one is going to be 0. I missed that multiplying.
Okay.
So still answer will be this limit will be 0, right?
Yeah. Okay.
Because of this sign.
Okay. So 0 by 1 we conclude it as 0, and then that is where it stops, is it?
So yeah, yes.
Okay. And then we go for the next term, that is the cos xy. Okay. Okay. All right. Thank you.
Thanks, Ravi. So yeah, okay. So that's all. So if you have doubt, you can, or we can now stop the session also.
In this context, can I contact you by email or something if there is any clarification that I need? Or is there a possibility? Yeah. Can you share? Can you share your email? Sorry.
Sorry, email.
Yeah.
Which context? Like
regarding this limits, I understand a portion of it, but I have not really gotten everything that is there to it. I'm yet to go through some of the videos.
So
that's
okay. So this all things in whatever I just tried. This is all thing related to the calculus portion, the math one portion.
Okay.
And actually, specifically, this is related to the L hospital rule portion.
Yeah, last term portion only, sir.
The thing is, I actually came as a lateral for diploma in data science, so I just went through the exam, and this portion of calculus I'm not very comfortable with. That's the reason.
Okay, so you can now rewatch again if you want doubt.
Okay, all right, thanks.
Okay, that's all for today, I think.
Thank you.
Thank you so much. I hope most of the doubt has cleared. Thank you so much.
The last step, we multiplied the numerator and denominator with that big expression to get the form of sine x by x, that form, no, sir?
Yes, sir.
The last line.
This one.
Not that one, sir. The last one. For the intention was to finally we have to reach that.
To reach the intention was see. Suppose you have like this. If you want to find limit as x goes to 0, sine, let's say some constant cx time upon x, still you are able to get limit of that. What is the process to get that? You can multiply it c time above in numerator and denominator also. Now this whole thing is changed to be as like this limit as x goes to 0, sine cx upon cx into c. Now this is look like a sine. If you assume cx as a y, so it will be limit as y goes to 0, sine y upon y, and this limit is 1. Cx is equal to y.
Right. Yes, sir.
So I think it is not necessary to remember this. If you directly apply L'Hopital's rule there, it will also work.
It will cos, yes, correct. Cos x upon 1. So it is, it will work. So, correct. Okay, yes.
Sorry, sir. I didn't understand that.
Actually, see, if you want to find the limit of it, limit x tending to 0, sine x upon x. So actually, this is in indeterminate form also, no? 0 by 0 form also. We can apply the L'Hopital rule here. So it is going to be cos x upon 1. Now find the limit as x goes to 0 and cos 0 is 1. So that's why sine 1 have limit 0. So also, you can apply here itself. Sine cx upon x if you have.
Yes, sir, I understood.
Right? So if you apply the L'Hopital rule, you will get C.
Okay, sir. Thanks.
So thank you so much. Have a nice day. Still remain some.
Thank you, sir.
Is there any revision session for our exams?
So on 6 and 8. Revision session is on 6 and 8.
Okay. Only one or two?
Two, and one is 6. One is on 6, and another one is on 8.
Okay, sir.
Already announcement and in your Google group calendar, the Google calendar has already mentioned that.
Okay, sir. I'll check. Okay, thanks.
Thank you so much.
तो ये है कि चलो